Today we are learning about simplifying radicals. Simplifying numbers is what we're going to focus on first, and then we'll do the variables after that. So simplifying numbers under a radical, we just mean we are going to pull as much out from under the radical sign as we can. But when I say we're pulling it out, we're only pulling whole numbers out. So we're not going to be using decimal answers here. Now, to do this, we are going to focus on perfect square factors. All right, so we've got to be sure that we remember factors means the numbers we multiply by each other to get a number, and perfect squares are numbers that when we take the square root of them, we get a whole number. So we're going to make a quick list of our perfect squares and use that as we work through the problems. Okay, so here's our list of perfect squares. Now, I just went through 100. We're going to keep it to these smaller numbers for right now. Now, we make this list by just taking numbers 1 through 10 and multiplying them by themselves. 1 times 1 is 1, 2 times 2 is 4. I forgot 9. One moment. There's 9. 4 times 4 is 16. 5 times 5 is 25, and so on. So that's how we make our list. So let's start off. Let's start off with the example, the square root of 12. Okay, first thing I'm going to do is look for my factors of 12. Well, that's 1 and 12, 2 and 6, and 3 and 4. Okay, I'm going to tell you right now, we don't need to worry about the factors that include 1 and the number itself. And we really, for this purpose, we're not going to focus on 1 as a perfect square. So with that said, let's look at our 4 factors that are left. Do we have a factor that is on our perfect square list? Yes, we have 4. It's right there. That is the only perfect square we have. Because of that, we are going to use these 2 factors to simplify this problem. So I am going to rewrite 12 as 4 times 3. Now, what I'm going to do is I am going to look at the square root of 4, and I'm just going to answer this question. The square root of 4 is a whole number 2. Okay, so now I'm going to cross out my 4 there. Now, what is left under my radical sign? Just the 3. So, square root of 3. Now, I cannot pull that 3 out from underneath the radical because the only factors of 3 are 1 and 3, and neither one of those are perfect squares. So this is as simplified as I can get, and this is my answer. Okay? Let's try another one. Here is the square root of 48. We need to find our factors. Okay? So if you want to pause, I'm going to put the factors up here very quickly, so if you want to pause it and find the factors on your own, go ahead and pause now. Okay, so here are my factors, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. I'm looking for numbers in these factors that are perfect squares. Well, I've got a 16 here, that's on my list, and I've got a 4. We know that's on the list from the last one. None of the other numbers are on my list. So what do you do when you have more than one perfect square? We are always going to focus on the biggest perfect square. So I am going to use 3 and 16 as my factors. So I've got the square root of 16 times 3. And again, I'm going to focus on one number at a time. What is the square root of 16? It's a whole number 4. So I'm going to cross out the 16. I've taken care of it. What is left under the square root sign? It's a 3. That's all that's left, and that cannot be simplified anymore, so this is my final answer. Okay, let's do another one. Actually, you guys try this one. I'm going to have you take or simplify the square root of 20. Hit pause now, because in a second the entire answer is going to be up here. Hit pause now. Okay, here is the correct answer to square root of 5. You can see here I did my factors. Okay, I found the perfect square factor of 4, so I used 5 and 4. When I came over here, I took the square root of 4, which is a whole number 2. That left me with a 5 underneath the radical sign, and I cannot simplify that anymore. Okay, so I hope that made sense. Let's move on. Okay, so now we're going to simplify variables underneath the radical sign. Okay, and by the end of it, we're going to put it all together. So the easiest thing to do is take your index of 2 and your exponent of 6, and we're going to divide. 6 divided by 2 is 3. So the square root of x to the 6 is 3. Now let's check to see if that works. Now the square root means multiplying something by itself. So if I come over here and I do x cubed times x cubed, I'm multiplying my answer by itself. When we multiply like bases, we add the exponents. That gives me x to the 6, which is what's underneath my radical. That's why it works. Okay, let's try another one. The cubed root of x to the 6th. Again, I am going to divide my, just a moment, got something not working here. There we go. I'm going to divide my exponent by my index. My index is 3 this time. 6 divided by 3 gives me 2. So x squared is my answer. Now again, let's make sure that that makes sense. I am multiplying this by itself 3 times, because that's what my index is up here. Okay, so x squared times x squared times x squared. 2 plus 2 plus 2 is 6. Okay, so with that in mind, we are going to move on. We're jumping to a rule because I do not have a calculator visible on here. If you take the square root of x squared, we get x. But if you graph y equals x, you should get a straight line. But when you graph the square root of x squared, you get a v. And we happen to know that a v is the graph of the absolute value of x. Okay? Now, if you take the square root of x to the 4th, that gives us x squared. We know that should be a parabola. When you graph the square root of x to the 4th, you do get a parabola. So we do not need absolute value marks. When you, if you take the square root of x to the 6th, you get x cubed. This should give us a cubic curve. But when you graph the square root of x to the 6th, you actually get something that looks like a parabola. So let's think about that. The cubic curve looks something like this. What's happening is all of these negative values, when we put them into this expression, your answers are all positives. So what we're going to do to make x cubed equal to the square root of x to the 6th, we are putting absolute value bars around it. So let's look here. We have an even index of 2, it's understood, an even exponent of 2, and an odd exponent of 1. Down here we have an even index of 2, an even exponent of 4, and an even exponent of 2. No absolute value bars. Here we have an even index of 2, an even exponent of 6, and an even exponent, or an odd exponent, excuse me, odd exponent of 3. So even, odd needed absolute value. Even, did not need absolute value. Even, odd needed absolute value. So here is our rule. If there is an even index of an even exponent that gives an answer with an odd exponent, we must use absolute value signs. Now, I don't know about you, but all that wording is kind of weird to me. So I am going to put this in a picture, if I can write appropriately. Even index and an even exponent, when it equals an odd exponent, we have to use absolute value signs. Okay? So let's just make sure that we understand exactly what that means. We have the square root of x to the 16. 16 divided by 2 is x to the 8. Since this is not an odd exponent, I don't even have to check it. Okay? How about the square root of x to the 14? 14 divided by 2 is x to the 7th. This is an odd exponent, so I need to, this one is odd, so I need to check this. I have got an even, and an odd. So this needs absolute value. Let's do one more. The cubed root of x to the 9th. 9 divided by 3 is x to the 3rd. Now here's the deal. This is an odd exponent, but this is not even, so I don't have to worry about it. Okay? All right, so let's look at what happens when our exponents are not evenly divisible by their indexes. So let's look at the square root of x to the 3rd. Now I can break this down into x squared times x to the 1 because 2 plus 1 gives me 3. All right, so the square root of x squared is just an x. I can't actually simplify that x anymore, so I just end up with x squared times the square root of x. Okay. Second one, the square root of x to the 5th. Well, we've got the square root. I can break 5 down into x to the 4th times x to the 1, because 4 plus 1 is 5. The square root of x to the 4th is x squared, and that leaves a single x underneath the square root sign. Is this making sense? So the square root of y to the 9th. I can break this down into y to the 8th times y to the 1. The square root of y to the 8th is 8 divided by 2 is 4. That leaves y to the 1 under the square root sign. Okay? So let's do two more. Oops. Number 4, we have the square root of x to the 4th, y squared. The square root of x to the 4th, we're just doing one thing at a time, okay, is x squared. The square root of y squared is just y. Well, for this, we've got an even. We do not need absolute values. For this, that's an understood one, that's odd. I've got an even, odd. So that means I need absolute values. Let's do one more. I'm going to write this one, and then I will show you the answer. M to the 6th, R to the 5th, hit pause. and then turn it back on and see if you get the right answer. The correct answer is m cubed, absolute value, times r squared times the square root of r. Now remember, 6 divided by 2 is 3, and this is an even, odd. That's why we have the absolute values there. Okay, now the r squared, we can break the square root of r to the 5th down into r to the 4th times r. The square root of r to the 4th is r squared, and that leaves the single r underneath. Okay, the homework is on the next slide, and let me know if you need help with it.